Hi everyone, I'm Sang Kim. In this video, I would like to share how to calculate Guttman's lambda 6 and the interpretation of our output. Let me use the same data which I have explained to you in the previous video. Let's import data into R. So let's see how data looks like. There are 20 observations and 6 variables, right? In order to do Cronbach alpha analysis in R, we can use alpha function. So let's activate the library PSYCH library. Okay. Then let's get the Cronbach's alpha. Let's save it as output, Cronbach output, and alpha. And data name, Cronbach data, and we need to specify column names here to include in the analysis. So Q1, Q2, Q3, Q4, Q5, and Q6. Right. As you can see, there is a warning message. So Q6 were negatively correlated. So in the previous video, I showed you the relationship between Q5 and Q6, and the relationship was negative. So in R, if you add check keys equals true option, it will automatically reverse the data, and will show you the output. But just leave it there as it is, because I want to show you how to get this output in this video. So let's see Cronbach output here, and after dollar, if we put total, then we can get same result, right? So I want to show you how to calculate Guttman's lambda 6 by using lambda 4 package. So we need to activate library first. Lambda 4, right? Then let's calculate Guttman's lambda by using Guttman function. All right, then let's use this data. And then we need to add one more option, standardized option. True. Right. So this Guttman's function provides 6 different types of lambda. So we are interested in lambda 6. Alright, so as you can see, 0.9714, 0.9714. Alright, then okay, let's calculate Guttman's lambda manually. Right, so we need to standardize data first. Let's use scale function. So Cronbach data. Right. So there are 20 observations and standardized data here and additional information. So we need to change it as data frame. And then let's save Cronbach output std. Right, there are 20 observations and 6 variables here. And the Guttman's lambda 6 means scaled multiple correlation. So we can get multiple correlation from regression analysis, as I explained in the previous video. So let's use rm function, q1, 2 plus q3 plus q4 plus q5 plus q6, and data, and Cronbach data std. Right? Cool. This is regression analysis. So we can extract residuals from this model. So $residuals. Right. This is individual residuals. Well, so we want to calculate variance of residuals. So let's use VAR function. Cool. This is the sum of variance of this model. So let's save it as RES1. Then we need 6 different types of model. So 2, 4, 5, 6, 2, 3, 3, 4, 5, 6. And Q1, Q2, Q3, Q1, Q2, Q1, Q2, Q3, Q1, Q2, Q3, Q4, and Q1 plus, and delete Q6, right? Then we need to add all these value. So let's say RES sum equals RES1 plus RES2 plus RES3 plus RES4 plus. Sorry, my computer is a little bit slow, so let's wait a little bit. Okay. RES5 plus RES6. Okay. Let's run. Okay, let's check. There's no error. Okay. Then Guttman's lambda6. The formula is 1 minus RES sum over. We need to add up all data in a row. So row sums Chromback data and STD, right? And let's specify column. So C. C 1 to 6. Okay. Okay. Yeah, and then we need to use variance here. Okay. So let's see. Yeah, 14.8. Yeah, 14.8. This number. Right. Then let's calculate this sentence. Right. This is same as Guttman's lambda6 here. Right. Additionally, let's explain a little bit more about our output. So let's see back data output. I explain about total. So if you choose alpha dot drop, you can see this result. So I explained to you, what each column, how we calculate each column in the previous video. Just I want to explain a little bit more about the last one, this one. So the first column is actually means once we delete Q6, what's the row Chromback's alpha, so 0.98. So once we delete Q6, we can expect higher Chromback's alpha, right? So there are two ways we can consider for in terms of Q6. We can delete Q6 or reverse the coding related to Q6. Again, as you can see, signal over noise. Also, compared to other variables, Q6 shows very high Sn. Because once we delete or reverse Q6, we can expect a very high signal over n. It means that we definitely need to change. Definitely we need to change how to consider Q6 in this model. So as typically, if you compulsorily need to add this variable in the model, then I recommend you to reverse the coding related to Q6. Alright, so this is the main output related to Guttman's lambda6 and how we interpret Cronbach's alpha in our output. I hope it was useful for you to understand Guttman's lambda6 and how to interpret our output. Please click like and subscribe if you want to see more useful and practical video in the future. Thank you.